So we got a few more rules for exponents and logs, and then we'll be done. So it turns out all we've been doing is looking at logs base e and exponentials base e. What happens if they are any other base? Let's look. Hey, so this is what's known as the change of base rule for logs. And what we'll do is, if we want to find out the derivative of a logarithm of any base, we can just take the derivative of this and see what happens. If we had rewritten it, another way of rewriting it is probably to say, whatever that base is, this is a constant. That second part's the variable. So when we derive it, that should tell us exactly what our answer is going to be. It turns out the derivative of the natural log of x is, not surprising, 1 over x. But we still have that constant out front. 1 over b is a constant. It's just a number. That's our derivative rule. Same thing for an exponential that's not base e. Here's another way we can write it. See, I don't know if you remember this, but when you have an exponential to the power of a natural log, these are inverses. That's just equal to b. So it's the same as b to the x. Well, derivatize, that's not really a word, but take the derivative of each of these sides. And you realize that when I'm taking the derivative of this, well, the derivative of e is just exactly the same thing times the derivative of this entire upper function. And since that's x, I'm just going to be multiplying by its coefficient. Another way to write this is, since this is equal to b to the x, that is our derivative rule. Whether you actually understand where these derivative rules came from or not, you still have to memorize them. But it is all based off of those log and exponential properties that you might have learned in pre-calculus. For the integral rules, we're just going to kind of do this backwards. Integrals and derivatives are inverses of each other. When I take the derivative of an exponential, I multiply by the natural log of whatever that base is. When I take the integral, I'm just going to divide. Up here, I could do the same thing, but then I realized, why bother? It turns out that whenever you have a variable in the denominator, it's just going to be a natural log. You could work to create a rule that would become a log of another base, but there is absolutely no point in doing it. No! We're not doing a rule for that. And light green markers don't show up very well on video, apparently. So, sorry you couldn't see that. You know the drill by now. There's a few examples, but we've already done all the examples you would need to. I just want to let you know, when you start doing product rules and quotient rules of these, the answers look terrible. They might be very long. That doesn't mean they're incorrect. That actually just means you're probably doing it right. And there's not much you can simplify. So get used to ugly, at least in your, answers for this section. Hopefully not your prom date. Okay, so real quick, you take the derivative of an exponential. Exponentials, we know, are going to be the exact same thing times the derivative of whatever their power is. But when we are doing this with a base other than e, take the log of that. By the way, if it is a base of e, you can still take the log of e if you'd like, but that just equals 1, so that's a silly waste of time. There's your answer. Same thing here, we're doing a log, we're going to take 1 over that times the derivative of that, oops! But remember to include the natural log of whatever that base is. Even if it's base e, you could write that, but I'm not make fun of you, because log of e is just 1. So there's really nothing that makes that look any prettier. Sorry about that. And then finally, for the last one, don't forget u substitution. If you have an exponential, u should be equal to it should be equal to the power. Let u equal the power, and you'll have the power to finish this problem. Please, when you get your answer, do not try and simplify this. You can't take 2 times 5 and make the base 10. That is 5 to a power, and then you'll double it. But you cannot double it before taking the power. That's all. Peace.